I'm Adam Klaus, and welcome to the Wilkes Land Expedition. It's really great to have you all here.
It's the beginning of a great adventure.
We're going to drill.
We're going to drill deep.
We're going to drill very deep.
Good morning, world. Here we are on the far edge of the planet, looking over Antarctica.
We have arrived to our spot. Perfect.
This is why we're here, to study this huge ice sheet.
One of the real strengths of an IODP cruise is that you have these diverse but complementary groups of specialists. So there's the physical properties people, the sedimentologists, people doing magnetism, micropaleontologists, and the geochemists. And all of us are working together to extract different but complementary data sets from the cores. And working together, they might be able to tell us quite a lot about how those sediments were deposited.
As a sedimentologist on the ship, we see every centimeter of core that comes up. The core comes on deck, it equilibrates, warms up to room temperature, goes through some measurement systems. We're usually the first to see if there's some big change in sedimentation or a change in color. Bring your camera, follow my finger right over to this. Look at this thing here. Maybe move over there and shoot at it back this way. So this layer here, it's maybe 2 or 3 millimeters thick. You know, that's probably the death event, the end of the summer. In the Antarctic, we have 4 months of kind of bright, warm sunshine, warm in this case meaning temperatures slightly above zero, and then all of a sudden it gets dark, it gets cold, the ocean freezes, and the plants die. And when they die, you get this big dump. They call it the autumn dump event. This layer of plant debris sinks to the bottom and it makes a layer just like that.
So all of these groups are working together, and all of the individuals in the groups are providing pieces of a jigsaw puzzle, and then when we put them all together, we get a bigger environmental picture. And using all of these techniques, we can track changes in the environment.
How can that be? How can it be so warm that right here in the Antarctic there will be, for example, crocodiles running around?
One of the big unanswered questions in paleoclimatology is what's going to happen to ice? What's going to happen to sea level as we continue to see these rising levels of emissions? If we go back to the Eocene period, there was little or no ice at all on Antarctica. And we're trying to get the first sediments that are taken just close to Antarctica. And with the biomarker measurements that I'm trying to do, we really want to extract 3 key pieces of information. What was the sea surface temperature like? What was the land temperature like? One of the biomarkers we're using comes from soil bacteria. And also, what was the vegetation and the plant types like that may have been blown off or transported from Antarctica into the ocean? No matter how good the models are, they're always a simplification of the real world. Whereas with the IODP, we can go back and make these measurements through time, through continuous undisturbed sequences that are not available on land. We can only get them from the oceans. And we're looking at the real world. We're looking at real history.
Quite interesting is that we get from the super greenhouse world, we are getting values that they cannot reach with the models. And that points to a significant sort of gap in the knowledge of the physical atmosphere characteristics or things like that, where the data now show, I mean, you know, crocodiles don't lie. I mean, it means that it was freaking warm. And they, whatever they do, even if they raise CO2 values through the roof, they cannot come up with those kinds of temperatures. And that means that there must be more interaction between the data folks and the model folks. And that's precisely why we're here. We are getting this solid data from the field. They then can use that into their models and to go into a new mode of better understanding not only past climate changes but also future.
And then the final success will be really measured in the coming years, maybe even a decade as we publish our scientific papers. So it's our duty to do the work to produce the data, but really we have to publish the papers. And then if the climate change story from those papers is important, then that has to go beyond just the scientific literature. It has to be communicated to the public and to policymakers.